We're going to talk about materials today because it's something that we've kind of glossed over, but there's a lot of fun you can do in Unreal, and it's a lot of the fact that it can do real time is in the way it renders these materials, or as otherwise known as shaders. We're going to be using a company called Algorithmic. I'm not going to spell that. It was called Substance Designer. So this is a plugin you might have seen on your Unreal Epic Games launcher that has this whole material integration. It has all these exposed parameters, and you can really get deep into this for making amazing materials. We're only going to be using a little bit of it today. Something called Bitmap to Material. If you're on a Mac, you can use for free a program called Crazy Bump, which is what I've been using for forever. It now asks for a license for Windows. We found that out the weekend. But yeah, the Mac is free, but I'm on a Windows. Why do we have so many fights between operating systems? Come on, guys. Again, this is probably cost something, but I have an EDU email, and so licenses are educational, and I got it for free under student licenses. So when you sign up, make an account, and we're going to be using Bitmap to Material. We're going to be taking things from Google Images and turning them into physically based rendered materials or shaders inside of Unreal. So first of all, let's talk about physically based rendering. It's called PBR textures. Booyah. So what you have to know basically is that it's emulating the way light naturally hits textures. So this texture right here, what can we describe this as? I mean, we know what this is, right? But what would be kind of like, speak out, like what are some of the features of this texture aesthetically?
Metallic.
It's metallic, okay? So what is that implicit? Like, what does that mean for you?
Firm.
So that's great. It has a texture, right? It has a coarseness. It has a certain kind of thing. So we inside a physically based material, that could be the roughness. So we could generate a roughness map using the software we're about to use. You notice that there's some darker areas. That is shadows. So the shadows help give it great depth, and by generating a shadow map, we can give it an illusion of depth without having to actually create geometry for that depth. This is especially important if you're getting into VR to leverage shader tricks and not have to do actually model all these diamond patterns and just use materials and shaders to help us out. So that's called ambient occlusion. We're going to be generating ambient occlusion maps. Anyone know what the wider areas are called? Glossiness or specular highlights. So we're also be creating specular maps, and then there's a certain way, the property of how light hits a material and bounces off that also gives us depth, and that's called a normal map. And these normal maps are quite beautifully aesthetically. Let's just look up normal maps. Normal map is a place apparently. So these are normal maps, and you'll see how these will give even more depth and offset to our material. It is only on 2 channels. I think it's not on the. It's only on red and blue, maybe not on green. Anyway, if you ever want to drive these in real time, you can separate out RGB and just add scalar parameters to just R and B channels, and make it have a real-time effect of growing, which is kind of cool. Maybe we can get into that today. And but we're going to generate all this stuff with Bitmap for material. I'm going to show you how easy this is. I'm just going to somebody name a cool material. Just say what was that? Sponges is amazing. Thank you. That is a good one. I've never done sponges. So I'm going to do just sponge, and then I'm going to be looking for a tileable texture. I want something that is going to be seamlessly repeatable. So I'm going to look up tileable. And the other thing I want to do is I want to make sure it's square. This is not as important as it used to be, but materials often you'll find are in powers of 2, starting with 512 by 512, 1024 by 1024, 2048 by 2048, 4K, 8K. That's it's the easier way for it to be stored and processed by the CPU. It's not as important anymore. These computers can do all sorts of things we have no idea. But it's generally that's what you're. If you have a texture artist give you textures, he's going to give you it in that, or they will give you it in that format. So sponge, tileable, and for my tools, I want to give it exact size, and I'm going to say that it's exactly 1024 by 1024. Which means if I got really close to it, it probably would start pixelating. But for anything just on my laptop screen, which is 1920 by 1080, it'll be fine. Let's go back to sponge and tileable. Look at all these tileable sponges. Wow, so many beautiful things. Oh, there are these. That's gonna be interesting. Yeah, that's like a real deal. So let's view that image and download that. We could deal with a few of them. Yeah, it's got watermarks, but that's fine with us today. You guys know how to get rid of Wait, can I do that in the recording? You guys know how to get rid of watermarks, right? You take the image and you copy it over and you make it additive. You can do it with video as well. Yeah, you just look it up. It's how to get rid of water. Okay, I'm just joking. I mean, you can, but we're not gonna do it. What is this? This can't be tileable. It is. All right. Well, we'll see when we get in there. All right. So we got 2 images. That's great.
So the resolution of the image doesn't matter.
Yeah. I put a search setting for 1024 by 1024. Right there. 2048. Sorry, did that answer your question? Okay. So you'll see that these tileable textures do come in that because that's like kind of the standard thing. But I think sponges was great. Oh, that's pretty darn cool. Anyway. All right. Anyway, let's moving on. So let's fire up the bitmap to materials. Here it is. Boyo. So it says drop bitmap here, and that's what we're going to do. Bitmap meaning an RGB image, PNG, JPEG, TGA, what have you. Let's go to my downloads. And let's... Didn't I download them? Sponge. They were like these long names. We'll go find it. Come back to me. They're in some random place. Boop. Now here we go. So this image, I'm gonna drop them in there. And if anyone was hanging out with me this weekend and we tried doing this before, I dropped them here, and I said, "Oh, it is the base color," but it still had the watermark on there. So you drop it actually here, where it says drop, and you say, "Yes, it is my main." There it is. Let's do this one. It is my main. All right. So what we have is a main, and it's automated a roughness map based off of that. A metallic channel, which doesn't seem to be metallic at all, which is smart. The normal, see that? Look at that. That's how the light's going to bounce off of it. Height map we can use, and that's the shadows built in. That's genius. That like we're going to have an amazing material, and it was just automated. And you can kind of see a preview of this guy right here. See how it looks in this world. It's not as not as much as if we had modeled it, but this is a great quick thing for roads and walls and all that kind of stuff. And I like that it's in this field. You know, this is where I go to look at where's my woman dancing. Where's she's supposed to work? She's with her shadow here, right? A minute ago. Anyway, So that's all we do. There's so many other settings you can dive. There's a lot of tutorials. You can look at it. There's one thing that I think is great about this one that Crazy Bump doesn't have is it has grunge. Especially if you have something that tiles a whole bunch, it might the patterns might become apparent, and you can add this procedural grunge to it, which just kind of mucks it up a little bit and breaks up the settings. Let's see. Grunge choice number 5. You can barely see it because I think the yellow is such a bold color, but you can kind of see it breaks it a little bit. And who doesn't want to have grunge on a sponge? This is Dr. Seussian now. Grunge on a sponge. All right, so I hit export and give me all of them. I'll sort it out when I get inside of Unreal. And what format do I want them? Doesn't matter. TGA is actually the native file format for Unreal. I just come from the PNG world, so whatever you want. And exporting it to my downloads, and then boom, we have all these things. So let's get an Unreal. I don't need this anymore. And let's fire up a level. And we're still sticking with 4.16. I saw people doing a lot of homework in 4.17, and then we couldn't. You can't. The engines aren't backwards compatible. So if you want to go back to 4.16 to use the Perception Neuron plugin, which is at 4.16, the Live Action plugin, which is at 4.16, the OSC plugin that's at 4.16, you're going to lose some of your work. So let's stay in 4.16 until we see more compatibility, and then you can always upgrade much easier. And we'll go over that.
Throw all those maps in the Slack real quick so we can follow.
Maps in the Slacks.
Yeah. Good evening.
What I'll do is I'll give you this this PNG, or even better, I'll give you the link to the PNG, and you get to roll all your own. Slack attack.
Slack it to me.
Slack it to me.
Okay.
Slack attack. And if we're going to do roll our own from home, wow, that's a lot. We can, what was it called? Downloads. Sponge. Also, try avoiding doing what I'm doing now, which is putting attachments directly inside of Slack, because we only have we have a free account that only has 2 gigabytes. So if you upload I don't know, like a 750 megabyte project, Alex, then that's half of our Slack for the rest of the semester. I'll always say, send me a link to download from your Dropbox or Google Maps or Google Drive. I would never call it a student class. Yeah, especially on screen recording. All professional here. Yeah, yeah. There you go. Okay. I mean, you did raise your hand, but you can't see the raising the hand on the screen recording. Yeah. So this is week 5. And I don't need any of their starter content because I'm going to be making my own content today. Well, that can't hurt with starter content. That's fine. So we'll do a blank, and we'll call week 5. Great. Maybe today we'll also talk about where to get some 3D models so that we can not just using the same primitive shapes. Alright, so I'm going to make my assets folder, my own project. I don't know if you guys saw as you migrate projects, content over, it makes their own root folders and stuff like that. You know, I'm starting off with an assets folder because this is going to be a small project. But let's say I was working on a project I was working on for the rest of the semester. I might just make a folder for my project name, you know, final project name. and then make an assets folder in there because you'll see things you can move or copy. You usually probably want to move, so you're making additional copies, and that way as you migrate more stuff over from other cool assets, you can keep things a little more organized. And then inside of here, we're going to have textures, and then also materials. And I'm going to bring in our textures from the downloads. There's way more than we need here, but that's fine. And let's make a material. And this is going to be called sponge. I'm going to say uppercase, oops, not in folder, uppercase M, material, and then sponge. When we start getting more into workflow with group, you'll see that there is actually an Unreal style guide that'll help you with naming conventions. And it tells you how to kind of prepend certain things for blueprints and materials, skeletal meshes, materials, textures, that kind of stuff, so that you guys can find your share your projects with each other a little easier. And let's open up Sponge. So we've looked at blueprints for the past week, maybe even 2 weeks. This is another node-based network thing for doing shader math and dealing with video textures and sprite sheets and all sorts of stuff we'll get into. This is our material node, and it has a lot of settings here left that I'm sure you can they're pretty self-explanatory, but we have what is the blend mode. This is going to be an opaque. We could also make it, let's say, masked, which means it has areas where alpha, where we can see through it like a window pane or something. And then you have translucent. And I think we looked into that a little bit when we were looking at the Fresnel shader, that you can have a gradient of transparency. We're going to keep this opaque for the sponge. And then we can make things unlit if they're going to be emissive. Let's say they're going to be a TV screen. It's an unlit because it lights itself kind of thing. We're going to be a default lit, which means by default it could take shadows and lights and stuff like that. You can see there's all sorts of cool things. Clear coat is for auto body painting jobs, and you have subsurface, which is like skin and some other stuff. We're just going to keep it default lit, and then all the other settings are fine. And then you see right here some of these things we just talked about: metallic, specular, roughness. These are all things we were just describing about the textures out there. So let's bring them into here. There's two ways to do that. We have textures, and then we can just drag them in. So we have the ambient occlusion, which I know we want. I know we want the base color, and definitely the normal maps. And let's see what else. Probably there's no specular, but there might be a roughness. Let's see. I think I brought in more than. Let's see. That's the sponge. That's a sponge. That's a sponge. And then we'll bring in the roughness in just 1 second. So I can just drag these in. There they are. Or I can select it, and then with it being, we've seen context sensitive before with the world outliner and blueprints, I can hold down the T button and click in there, and it's brought in the one that I had selected in my content browser. So there's a lot of ways to go about this. And then we're just going to bring this in to our connect the nodes. We have base color. What was this one again? This one says ambient occlusion. That's down here. Ambient occlusion. What was this one? This was roughness. Roughness. Cool. And this one's normals, and that's right there for normals. So now we've kind of recreated, we can see there, we've kind of recreated the sponge that we had inside of the other software. We have some other things we can bring in. Looks like glossiness doesn't make any sense because that's a sponge. And specular really wouldn't be there. So this is good. Alright, so let's save it. And there's where you might see it compiling shaders in the bottom right. And we can go over to our material and just drag it in. Spongy table. Cool. So this looks like a huge sponge, right? Like that, the sponge that this came from, like the real animal, would be huge. So we want to scale this a little bit differently. And the way to deal with coordinates inside of shaders is with a thing called U and V. Now we've spent a lot of time on X, Y, and Z, right? So what is U and V? U and V is a way of talking about horizontal and vertical, but within the space of X, Y, and Z. So it's an orientation based on itself, and we can tell which kind of orientation it has, whether it's based on how it's relating to the screen, relating to other objects, or relating to itself. The most basic way is just for it to be relating to itself, but having a horizontal and a vertical scale. If I click and hold down the U button, I have UVs. We'll do more with these later on, but a UV is essentially a red gradient and a green gradient overlapping each other from 0 to 1 on the red and green channel. To prove that, we can mask out one of the layers. And here I can twirl down here and I can be able to preview. Alright, so I'm going to mask out G, and there we see we have a gradient just on one channel. Right? And this is really helpful for making using shader math. Like right here, we're not using any PNGs. If we get into making particles, we'll use shader math without even using any PNGs, so that we can have particle counts in the hundreds of thousands without having to worry about rendering all this different images over and over and over again. But let's say before I plug it in, well, actually, yeah, let's plug it in. All right, this will be the exact same as it was before, but now when I drive some of the U and the V channel, we'll see how it'll scale. So I could say, let's bring this guy up here. If I make it smaller on the U, it actually got bigger. Let's go bigger. There, we see we're tiling more, right? So now you can see kind of repeating a lot more. And this is where that grunge kind of helps out a little bit to help hide some of these patterns. And if we save this, it updated itself, and this is a more reasonable sponge table, if you're into reasonable sponge tables. And then I could probably tweak it a little bit more. Cool. That looks even better. I want the whole world to be sponges, though. I'm just dragging it onto the objects. But if I had selected the object and then there is a material element there, you see how it turns green and says yes. And so that scale doesn't seem to work for the floor as well. I'd probably change the UVs for the floor. Well, actually, if you want to jump into that, we could talk about that. What I would do is actually I would make a parameter here. And the parameter would be able to make this one be a base material, and then I can make instances of this base material, because let's say it took me forever to get these textures, and man, I am good with this. This is going to be used a lot. We're making a sponge video game, and everything is going to be sponge. So we want to be able to make a lot of permutations of sponge, and I don't want to keep on copying and pasting these in all the time. So texture coordinates, as I said, are U and a V. So let's make a parameter for U and V. All right, a parameter just means like it's a constant that can be scaled at real time. It can be something that can be driven through some sort of input from the performer or show control. So you see right here, here's some of the things I could drag off into the materials. I can also right click. Oh no, right here is what I do. Bring it in. I'm also just going to hold down 1 and click, and now I have a constant. The constant is 0. If I right click on that, I can change it to a parameter, and I can give it a name. UTile. Alright, and then I'm going to control W, which duplicates, and I'm going to make this one a VTile. Alright, and then it has a default setting. What are my default settings like here? 10 and 10. Let's make it 10 and 10. 10 and 10. I'm going to return this back to the land of ones. And I don't know if you guys have done much shader fun, but it's just a bunch of math properties. These are two values that sit next to each other. If you look right here, it's basically u comma v. So we're going to append these to each other. Append. And then we're going to just take this value right here, and we will add it. There we go. And so now,
You want a hotkey to add it?
A. And those are all listed here. There's a hotkey for it. Otherwise, you can just drag it in. Shunk. And there. Also, what you can do is if you hold down Control and drag, you can drag things around to different things. And then Alt and click gets rid of them. It goes Height. Alright, so this is 10 and 10. Let's see. There's a guy in there. Looks like it's not the same thing. I might be making a mistake. It might be multiply, which is the M button. So I'm going to hold down Control and then grab this whole mess and just plug it in there. That was multiply. Okay, never mind. Add is we're going to do something else, and we probably won't do that. Okay, so what I have here now is a base material for sponginess that I can now have two parameters I can drive. All right, great. I'm going to take this and rename it base. msponge base. And when I right click on it, it says create a material instance, and that's what we're going to do. We're going to create various instances of this that are all being derived from a base material. So this one can be called whatever I want to, msponge base instance. I can call it msponge base or large, right? And then I'm going to go back to the main one and create another instance, and this one could be small. And I think that I want to have the large on this guy. Nothing should change. It's just we know it's changed over here because this is the same settings as before. And then the small we'll put here on these. All right. So what's great about having an instance parameter is that you can actually drive it at runtime. We're basically, when I open up this, it's a different layout, right? And when I check these buttons, I'm now, as I told you, game engines are kind of lazy. Well, now I'm saying, guess what, buddy? I'm about to start driving this stuff in real time. So start allocating some memory for this. Start getting ready for me to run this in real time. And now it's a dynamically instanced material. All right. And come back here. Great. So if I hit play, we're watching here the ground, okay? I'm going to grab my mouse back by hitting Shift F1, and then I can drive these parameters in real time. You see the floor? And this is how you can really dial in settings that you want. So this is parametric design of sponge floors. Yeah. Great. So you can see how this would be really important if you were, let's say, making a bookshelf and you wanted each book to have a slightly different color. You would make a parameter on a color that you can drive. Let's do that. Let's edit our base and let's multiply this sponge, and let's say we want to have different kinds of colors. So I'm going to hold down 3 and click, and this is a 3 vector. This is an RG to B, and right now it is black. I'm going to make it white, multiply it by our base color, so pretty much the same. And for proof of concept, you just bring up the color wheel, and now it's bluish, right? So we're just taking we're taking a color and multiplying it by our standard yellow. We can make a really yellow, super yellow. There we go. Great. Saving it. Oh, but it's not a parameter yet. It's just a 3 constant. Right click on it, convert it to parameter. We'll call it color. All right, and then when I save and I come back to this instance, this is the floor instance right here. Boom, colors available. So we unpin that, and it's still actually. I can't believe I was actually running the entire time. Oops, probably should have like stopped it and then hit play. Anyway, so now it's super yellow, and I can drive this while it's playing in real time to really dial in my settings. It's a little mildew. Yeah, it's mildewy. Yeah, there you go. Somebody's not cleaning the floor well. Maybe it's like under the sea. There you go. It's whatever I want it to be. I'm control the parameters. Great. So now you guys see like how it would be super easy to make a bunch of, once you have like a water, like a fire, these things are super complicated to create. You can start making these different parameters and changing these little things so that you can tweak them and have a little bit of uniqueness between all your stuff. So that's cool. And let's save all. Great. Does anyone have any other questions just about this stuff right now? Yes. A soft jiggle. A soft jiggle. Let's see. I would utilize normal maps maybe. And let's look up Jello normal maps. Is that such a thing? Ooh, yeah, there you go. Or this guy, that guy, that'd be really scary. That might be a little much. All right. So let's bring in this. Andrew, am I doing your homework for you if I do this? Okay. All right, so I've downloaded that thing. I think it was called like Jello something or other. I'm going to import it. You can imagine how it's important to put subfolders and subfolders to keep things organized. There's our normals. With it selected, I'm going to open up my base and just hit T. There you go. And I want to multiply it by these other normals. These are my sponge normals. And if I added it, it would make it 2, it would go over 1. You want to have these normalized ranges between 0 and 1 of this stuff. You have to think about this as like a grid of pixels, like a video or anything. And we want this to not go over 1, so instead of adding it, that's what multiplication is for. We're going to multiply them by each other. So we kind of have a jiggle thing, but it's not really apparent yet because we want to move it a little bit. So I'm going to do an object called panner. Bring it in. And let's get it going on the X. Bloop, bloop, bloop. Can you see it? Can you see it? Are you moving? Let's show this in real time. You're not moving. Constant coordinate. Speed. There it goes the other way. That's funny. We'll go this way. No, it's definitely not that way. What was that? No, it should be fine. I don't. Let's do it up here where we can actually see, and then panner. I held down P. It says no because it wants to go in front. I could look that up and then get it to you guys in a second, but. There we go. Does banner change how it does its thing? Hold Alt Control for more. According to the time input. Alright, well, I like time. Let's do time. And speed. And coordinates. Well, I see it moving, but just not consistently. Ignore pause. What is rotator? And this is gonna be the same thing, right? It already has a speed there. Yeah, so this is crazy. Alright. How do I teach Unreal? Take a T-chart and a whiteboard. Okay. Okay. So we're animating UV coordinates, and I know that I'm not crazy. You literally just do this. So well, I'll look into it. That's just kind of crazy that it wasn't working. It's very simple. We'll look into it later on. But it was a good question, though. It should have worked. Let's get everything back the way it was. There it was. I think. I don't know now. Everything's gone crazy. Alright. And the let's go ahead and move on a little bit to one other setting, which is the emissive setting, which is just one other thing that's kind of cool. And we'll kind of create the Fresnel from scratch, which we were doing before, which is, let's do it more with math. Alright, so here's one more material we'll do. Content, final project, assets, materials. We'll make a Fresnel together. Did we do that in class? No? Okay, so this is a kind of how you do a gradient, and it's called a Fresnel or Fresnel if you want to get, you know, Minnesotan with it. It's just a very thin piece of glass, and when you get to the edge of it, you see, you get to see some of it, but when you look directly on it, it's completely transparent. So only when you the instance on the edge of it does it actually is actually visible. So we're going to take two colors here. So I'm going to have color and color, which can be driven by parameters and stuff. You notice sometimes when it stays black, you need to move up. Okay. And then Control W, and I can do another color. Let's do, there we go. And what I'm going to do is I'm going to interpolate between those two. So, linear interpolate, otherwise known as LERP. And we have an A, which is like the starting space, and a B, which is the finishing place, and the color. Alright, so this is going to be, this is halfway between blue and orange. Right, it's an alpha, right, see over there, it's alpha of 0.5. It's interpolating linearly between these two. If I go back to 0, it's going to be blue. It's going to be what is the A. And if it's all the way at 1, it's going to be all the way at this yellow. But I'm going to use the Fresnel to drive the alpha. And now we have this thing where it's yellow on the outside and blue on the inside. Switch it up, and it's creating this Fresnel gradient. This is the opposite, right? And you're like, oh, well, I really can't see that very much. You have these couple settings, and we can change this exponent to like 1, and now it's a much more noticeable gradient. And we talked about alpha a little bit, and this is also pretty cool for making the material translucent. And we'll take another, we'll just do black and white. Say 0 is black, 1 is white. 2 of these. Both of these guys. Oh, no. Cool. And we'll go inside the opacity. I want to flip them. So now only visible like around the edge. You see that? But now you can do this. It's transparent kind of the center. And what's great about this is that Fresnel used to be an extremely expensive thing to render, and now we're doing it in real time, which is very, very, very cool. And we also with opacity have an emissive color, and that's also kind of fun to play around with. These values can be, let's say I want it to be, instead of lit, I want it to be unlit. So now it can't take any shadows. And we're going to put this into the emissive color instead. And now it like sticks out a lot more, right? It's a little more bright. I also can multiply this by a number. Bring it in. Give myself another constant. 0 makes it dark. And we're going to make it 1 here. And we're going to call this emissive. Cool. And let's put it on this floor. Oh, I'm doing this all while my engine's running. That's crazy. This is bad practices. So it's, see that? This is these cool incidents, like right when you get the edge, you can see it. Fresnels are definitely really, really great on bodies, dancing bodies. All right, so there it is. But we want to drive an actual instanced parameter on it. So let's put this in here, and we want to see how emissive we can make it. So I'm gonna hit play. Get down here low so we can see it, and let's drive it. So some of my James Turrell folks, this is how you kind of get into that, right? You know, isn't that cool? Looks beautiful. So you know, you have fun with materials this week. That's a huge kind of place for some creative expression. You saw how I was just doing math, right? Really do have fun with some kind of math. Oh, I'm going to bring in the wavy thing. Let's try one more time. I'm not going to give up. I have to redeem myself. So where's Mr. Wavy? You're going to save all. And you have an option to actually bring in a normal map here. It kind of adds a texture to your glass, right? So it has like this texture now to it. And I'm going to try one more time. Nope. Computer says no. No, we can watch Computer Says No next week. Maybe it's not, I'm not showing things in real time. Let us say show in real time. Oh, is that it? I'm an idiot. Okay, it was working all along. Redeem myself on record. There we go. So let's go back to our sponge, otherwise known as a sponge, and say do it in real time. Now it's checked. Oh, you're gonna be a pain, aren't you? Panner. Spongy. We just couldn't see the UVs doing it too much. That's fine. So now I redeem myself. I told you I was waiting for you guys to tell me, but no one did. F's. We really can't see it because it's too emissive. So we're like, well, we like this emissive thing, but it's a little bit too much. So maybe we need to bring it down so we can see the thing happening. So that's how you make it wavy. That's cool. Yeah, this is totally done. So this is materials. You guys have fun with materials, and if there's any questions, let me know. Let me I how I can kind of log into these computers. We can set up a sort of team viewer client, so I can like log into your computer to help you out if you have any problems. So